Okay, we're gonna derive the big three. Penta asked me, it's her fault. Okay. So you start with A equals delta V over T. And by the way, you don't have to do this. We're all looking terrified at this, but you don't have to do this. It's just that some people would like to see where these formulas came from, right? If you have that inquiring mind piece, and you just want to know where they come from, this is where they come from, but you don't have to be able to do this. So it all comes from this. Acceleration equals the change in velocity over time. The change in velocity is your final velocity minus your initial divided by the time. We can change that into, if we multiply both sides by time, we get AT. And then we add our VI over, so I do that 2 steps in one. And that all equals to the final velocity. And if I just flip that around, I get this formula, which is our first formula up on the wall there. Now to understand the displacement, a nice way to start is to graph it. So this is just a simple acceleration graph where you start at an initial velocity and you carry on to a final velocity. It's kind of a way to see it. So the displacement is the area underneath this graph, because velocity times time is the distance you've covered. It's just a way that I kind of start off with it visually. If I want to find out the area of this, you can split it into 2 parts, a little rectangle and a triangle placed on top. So this rectangle is the VI times the time, and that's VIT. And then the triangle on top, this side is VF minus VI, that's this distance, multiplied by the time again. But it's not the whole rectangle, so we have to cut it in half because it's triangled. If we add those 2 things together, we'll get the total distance covered. You can do this mathematically too, but I kind of like the visual way to do it. So I just wrote that out here. I said the displacement, the total displacement, is VIT, bottom rectangle right here, and half VF minus VI times T. Half because it's triangle, and we add that over here. Now we would like to have a formula with acceleration because we almost always know the acceleration. So acceleration is VF minus VI over T, that's what we started with. If we times the T here, we see that AT equals VF minus VI. So instead of having the difference in velocities here, we can say that's the acceleration times the time. We can plug that in there. And then it becomes this. So I just change this into AT. And then we can put those T's together, and we get our second formula. It's actually the third one on the wall, but it's number 2. After that, we go back to our graph and we go, okay, the area under here is displacement. Another way of looking at it is if I just cut this line in half, that would be our average velocity. So the average velocity is kind of the average speed you're going. It's right in between your final velocity and your initial velocity. So if you started at 4 and you finish at 8, your average velocity is going to be 6. So you take your average velocity, and that is your final velocity plus your initial velocity divided by 2. Just the average of the 2 numbers. That's the average. So if our total displacement is the V average times the time, then our T, if we solve for T, we put the average underneath. So we have D divided by V average. And then we take our V average, what we know it to be, the average of the 2, and we put that underneath. But when we put the average underneath, you're dividing by a fraction, and so you're multiplying by the reciprocal, right? So you flip it over and the 2 goes up on top. So okay, that's kind of cool. 2D over VF plus VI equals T. Why did we do that? Well, that's helpful because now we have a different expression for time that includes distance. So we take all that and we go back to our first formula and we plug it into the t in the first formula. Now, can they see the other board? Just twist it a little bit here. Now we move over here. Filling up 2 boards today. It's a big deal. So this now becomes this. All I've done is I've taken the first formula and I put our little expression we got for t and I put it into here for t. And so we put the a in there. We have 2ad over vf plus vi. Now we're going to take this bottom. We're going to multiply that by both sides. It cancels out over here. We have vf minus vi plus, times vf plus vi. So these are multiplied to each other. So you guys know the FOIL. We're going to do the FOIL thing because this is addition and subtraction, so we can't just multiply them. We have to do the whole thing. So it's vf squared plus vivf minus vivf minus vi squared. VIF minus VIF, 0. Gone. And that's all equal to 280 because we still have the 280 from up here. If we get rid of that, we have VF squared minus VI squared equals 280. And then if I just add this VI to the other side, the VI squared, we end up with this, and this is our last formula. That's the derivation of the big 3. You do not have to be able to do this. You can try it, it's kind of fun. You just try to start going, see where you get. It's messy, but it's fun. And so if you're wondering where this all comes from, you can derive it all from that original change in velocity over time is acceleration.